Today I'm going to be doing a kind of talk on Go interface. Now, the first thing that we have to do is understand what a Go interface is. You can think of an interface as a way to implement or enforce a bunch of method. So, for example, if I want to enforce that a bunch of methods are implemented by certain objects, is an interface for that. For example, if I want a bunch the getName method to be implemented by certain kinds of objects, I define a living thing interface. If I want to define that a bunch of methods are implemented by certain people, the method which are dance and other method, I can also define the people interface. But one thing you are going to realize is this interface is kind of different from this interface. This one has a method, this one has a method and living thing type, right? Now this is a way to do kind of hierarchy and inheritance. So this interface kind of inherits all the method that is defined here. So it's a very good way to inherit method from other interfaces. That's why we are doing this. Think of it as a lazy way of just having, instead of having to duplicate method everywhere, you can now just do inheritance. Now let's see, how do we in fact um, how do we implement an interface? How do we implement an interface? It's very easy. For this interface, to implement this interface, all you have to define is just the getName method. Now for this interface, all you have to define is just the getName, which is inherited from living thing, and the dance method. That is all you have to define. If you define those two things, you should be good with interface. You should definitely be good with interface. Now I have a type called African. It's a struct and it has name and country, right? Now it defines, I simply implemented this interface on it by defining the getName and dance. So when you run getName, it returns the name of the African, and it's also like the name of, and the second one simply says print I'm dancing. Now if you run this, right, I simply defined a type called African, and the next thing I also did was a type European. I defined the same thing, the European getName and also dance. I did that, and also get SSN. I did that also on the type, the struct type. So by defining these two methods, dance and getName, this European object type automatically implements these two interfaces, right? Because it actually implemented their method. Very, very easy. Now, what I simply did in this case is I created an array of people interface, array of people, right? People interface, and I simply pass in Tunde and John. The reason why Tunde and John is passed in without error is because both of them implemented the people interface, so it's not going to error out. Now, if you can actually test this. Let's say I update this to this, we'll probably get an error. You see, African does not implement people. It's missing the getName. You can see here. Now, this is interesting. Now, let's go to something more interesting than this. Now, what about if if as I'm looping through this people interface, as you can see, I know deep down I'm actually looping through Tunde, African type, John, European object type. I know both of them also implemented salary, as you can see here, on the object. But the question is, can I access the salary method from people interface? The answer is no. When you are looping through interface, regardless of the underlying object type, you are only restricted to the method defined in the interface. So if I try to do this, I'm in for a very, very big surprise. You see, people has no field or method salary. The reason is the fact that you're only restricted to the object defined, the method defined inside the interface, right? That's what you're restricted to. Now let me talk about something more interesting also. and the fact that if you try to switch this to a pointer, you are going to get a very interesting error. Let's remove this. You are trying to get a very interesting error. Right, let's run this without a pointer first. Everything ran fine. Let's switch this into a pointer. Okay, a pointer. All right, African does not implement people. Now the question you ask yourself is, if the requirement to implement an interface is to implement its method, we should have already done that. Well, there's something going on behind the scene. By defining a pointer receiver instead of an object receiver, you are implying that you might make changes to the object within the method. Remember, now the problem is when you call this method, in this case, getName, the object is being passed by value. So what that means is Go simply makes a copy of the object and pass it to this method. Right. So when this method in this case is expecting a pointer, right, is expecting a pointer, and remember Go passes in by what? By copying. So when you pass in Tunde and Tunde get passed to this method, what happens is it makes a copy of Tunde. So the object that this method is going to receive is going to be totally different from this one. Different address, different information. But by using a pointer, you are implying that you want to be able to access the original object. And remember, you are being handed a different object, different from the one that you passed in, because Go passes in object by value. So we have a problem. That is why you are seeing this error. And one way to fix this is to just pass in the pointer, right? So when you pass in the address itself, the pointer itself rather, we don't have an issue. Now, if someone that is paying attention, you will realize that this is a pointer receiver, is an object receiver, object value receiver. So what happened? The problem is, why is this one not showing an error? The problem, the answer is rather that the dance method, despite the fact that this is being passed a pointer, Go has the ability to dereference that pointer and hand in the original object value, right? So Go behind the scene can dereference that for you and pass this particular method the original object, right? Original object. Unlike the previous case whereby when you pass in by value, you are making a copy of the entire object. So you have a different object with different address. So if I hand in that object address to this pointer, I'm pointing to a totally different object in memory. I hope you get my point. So that's one of the issues you are going to see with interface. Now that's about that with interface. Let me also talk about something about interface. So I looked around, how do people use interface? Now, most of the time, people use things like a map of string, a map with a key of string and type of interface. That brings us to a very interesting type called empty interface. What are empty interface? Empty interface are just interface that do not implement any method. And therefore, object type automatically implements a interface. So therefore, empty interface is a way to accept any kind of object because every object implements empty interface, right? Because the empty interface requires that you have a zero method, right? So therefore, you automatically implement it. String, integer, blah, blah, blah. Since empty interface requires that you have no method, sure, everybody has implemented an empty interface. And it's a very good way to accept, different kind of objects. For example, this method itself is actually receiving an empty interface. That is why you're able to pass in different kinds of objects to it. Now, let's go behind the scene and run this. I'm creating a map, and the map is very easy. The map is just, the key is going to be a string and the value is going to be interfaces. Because of that, I'm able to pass in an integer and also a string to my map. So I don't really care what the value is going to be, because automatically the empty interface is going to be implemented in that particular object, right? So that's just empty interface. That's right now, that's all I'm going to be discussing about the Go interface. And if I have more information, better details, I'm going to upload it and I'm going to share with the community. Thank you. Okay, stop recording.